We started section 6.2, addition and subtraction of rational numbers last time. We finished the addition section and we are taking a look starting with the definition of subtraction today. Now there's an earlier definition of subtraction in chapter 3, so if you have had number theory, you have seen a version of this before. If not, that's okay. It says if a over b and c over d are rational numbers and you want to subtract, then the answer is the unique value e over f such that a over b equals c over d plus e over f. And what I want you to see that this is saying, here's that subtraction piece that it gives you, is that it will equal e over f. If you were to take this piece and add it to this side, you'll get this equation. So we see that? If you think about values, we can even use whole number values. There's nothing special about fractions here to talk about this. But the reason that 5 minus 2 is equal to 3 is because if you take 2, the value you have to add to it to get 5 is the number 3. So that's how the definition is set up for subtraction. It's asking you, what do you have to add to the second piece to equal the first one? Theorem 6.8 talks about what it means to actually subtract fractions in terms of adding negatives. So a over b minus c over d is equivalent to a over b plus a negative c over d. You're very well familiar with that idea now. I have this sort of voice in my head from 7th grade that says there's no such thing as subtraction. Did anybody ever tell you that when they were trying to introduce you to the idea of negative numbers? I remember that teacher. I remember her. I can see where her classroom is in my middle school right now. She was in a junior high at the time, but yeah, I remember her telling no such thing as subtraction and doing this. She drew this picture with the parentheses and stuff and so forth. So that's something that you've probably seen back in middle school. A couple other theorems, properties of subtraction. These two feel a lot like where we started with addition at the very beginning of this section. At least, yeah, yes, where we started, it was this section. So if you were trying to subtract rational numbers that have the same denominator, we simply subtract across the numerator and the denominator stays the same. So a over b minus c over d is a minus c over b. And again, a visual is a really good way to do this. I'll draw a circle and we'll think of it as a pizza. Hopefully you've already had lunch. And if you had this pizza, 8's a nice number of pieces. They like to split pizzas into. And it said you had 3/8 minus 1/8, right? You'd remove this piece and you'd be taking it away and you'd still have 2 out of 8 pieces left, right? So we're still having the same size of the pieces. That's why the denominator stays the same as we do this operation. Now on the second one, it actually talks about what we do when we have unlike denominators. And this isn't the only way to subtract with unlike denominators. But the premise is we need to get the denominators to match one way or another. And this one has that same smiley face, so if you kind of like that visual, it's a nice one again. We will cross and do our smile underneath. So you multiply our diagonals, and the only thing that's different between our addition property is that it's a subtraction sign between them instead of an addition sign. It does become very important that you make sure that you do the top diagonal, like you start here, as you do that, right? It's got to go from the top left down as our first product. When we did addition, it really didn't matter so much because addition is commutative. You can do it in either order. All right, so we're going to do an example problem with some subtraction, and this one actually has mixed numbers in it as well. Martine bought 8 3/4 yards of fabric. She wants to make a skirt using 1 7/8 yards, pants using 2 3/8 yards, and a vest using 1 2/3 yards. How much fabric will be left over? So this piece right here is my original amount of fabric, and all the other pieces are getting cut off of the skein, right? They're getting cut off of the original big long piece that we have. And at the very end, we're going to have a little bit left over. Does that make sense? Like without worrying about the numbers, does that make sense visually with what's happening? Okay. So in terms of what we're trying to do, we're trying to find that 8 3/4. We'll put the word, or the YD for yards on at the end. And we're trying to take off each of the pieces. Like literally if we were doing this problem, like in real life cutting the fabric, I mean, not doing the math problem, but cutting the fabric, you would actually cut off 1 2/3. I'm sorry, 7/8 is what's listed first. I'll start with that one. You would cut off the 1 7/8. And then you'd keep cutting and you'd keep going down the line. You'd say, okay, now I'm going to cut off my 2 3/8. And then you would keep going down that large original piece of fabric that you still now have, and you'd have to cut off the 1 2/3. So that's how you'd actually go about cutting the piece of fabric. Does that make sense? Now, that may not be how you want to go about solving the problem, because another possibility instead is that you could do the 8 3/4, and you could subtract all the pieces that are over here added together. Right? These are the 3 projects that I'm going to work on. These are the 3 amounts of fabric that I will need for them, and you might choose to do the addition first and then the subtraction just one time. It didn't really matter. It's a little bit different in terms of the values that go down the line with it. But those are 2 sort of different perspectives of the problem. So I'm going to suggest that we do the bottom one because it already does a lot of the things that we know how to do with addition. But if you do the top one, you'll be okay. Now, a reminder, there are 2 ways to deal with mixed numbers. One is the improper fractions approach, which is the one I'll do first. And then the other one is mixed numbers, and I'll show that one second. So if I work with improper fractions here, I need to change them all to have the same denominator, right? Now, I need to change them into proper fractions first, but eventually I need all to have the same denominator. So I have 8 3/4, and if you'll remember from last time, we multiplied and then we added all the way around. So 8 times 4 is 32 plus 3 is 35 over 4. So that's my first one. Minus, and then I'm going to do the other 3 all in parentheses. So I have 1 7/8. 8 times 1 is, plus 7 is, so I have 15 over 8. I have 2 3/8. So 2 times 8 is plus 3, 19 over 8. And then the last one is 1 2/3. So 3 times 1 is, plus 2 is 5 over 3. Now, we might as well add the first 2 together. They already have the same denominator, right? So we could go ahead and do that. You don't have to, but again, they already nicely enough match, so I'm going to go ahead and do it that way. What's 19 plus 15? I already have this one written down. What is it? Is it 34? Excellent. The nice thing about actually only having 2 values here is that if you want to, you can do the process where we made our smiley face. If you don't want to do it that way, you can recognize that 8 and 3 have nothing in common, so you multiply this one by 8, and you can multiply this one by 3. So I haven't actually showed that when working out, so I think I'm going to show that this time. They'll give you the same numbers everywhere, but 35 over 4 out here. You know what, while we're at it, let's just put this in 8ths as well, because we'll probably want it there in a little bit, so we might as well. So if I multiply the 4 by 2, I also get 8, right? Y'all good with that? Okay. So what is 35 times 2? So I have 70 over 4 on the outside. On the inside, I have 34 times 3. 72? Okay, I hope you guys are telling me right values because I don't have this. I'm doing it a little bit differently than my notes. How about 5 times 8? That's 40 over the same 24. All right, so now I have 70 over 4 minus, I'm sorry, that should not say over 4. That one should have said over 8. If you were copying what I wrote down, I apologize. Please fix that. That one should have said over 8. Okay. What's 72 plus 40?
Sorry, that's the wrong number. It should be 102.
Which one? The 72 should be 102?
Yeah.
Ooh, I'm glad you caught it. 102. Oh, we didn't really multiply by anything big enough on that 70 over 8 either. I wanted to multiply. I was looking at the 8 as my first fraction, but really want it to be 24. So how about instead of multiplying by 2 here, we actually multiply by 6? You guys good with that? That would give me a number over 24. So sorry. I zoom in and zoom out a lot on my screen, and sometimes I get lost in the details. What's 6 times 35? 210. Lovely. Over this 24, I would have in the other one. Okay. 210 over 24. All right. Then, what is 102 plus 40? 142 over my 24. All right, now I have 210 minus 142. $16? 68. That sounds more right. Good. 68 over 24. There's two problems. There's not problems as in problems to work, but there's two issues with 68 over 24 as my final answer. What are they?
You started a mixed numbers.
That's one of my issues, right? If I start mixed numbers and end in mixed numbers, I mentioned that last time. What's the other issue? But it's not simplified. 68 and 24 are both even at the very least, right? So while you can change it into mixed numbers at any point, it's actually usually easier to get it smaller and then change it into mixed numbers. So that's the way I'm going to go with it. So even if you aren't sure what happens next, it actually divides by something I think bigger than 2. But if you weren't sure, you should at least recognize they're both even enough to divide. They're both even and therefore could divide by 2. What is 68 divided by 2? 34. And 24 divided by 2? 12. Again, at the very least, you recognize they're both even. I'm going to try it one more time and see what happens. So this would be 17 on top and 6 on bottom. They don't reduce anymore after that point. Agreed? And so then we would do 17 divided by 6. How many times does 17 or 6 go into 17? 2 times, which gives me a 12 and a remainder of 5. So the answer to the question is actually 2, the number on top, the whole number part. The remainder is 5 out of the original 1/6 that I was dividing by, or 6 that I was dividing by. And I mentioned this early on that at the end we'd need to make sure we indicated that we were working in yards. Okay, we're going to do the problem now with mixed numbers. Give myself some more space to work. So this is the mixed numbers approach. Again, we can distribute the negative through if you wish. We can simplify within the parentheses. I didn't do it within the parentheses on my paper, but that's how I did the last one, so I think we're going to do it that way still anyway on this problem. So mixed numbers means that I group the whole number pieces together. So if I have 1, 2, and 1, that's a total of 4, right? And then I have 7 over 8, I have 3 over 8, and I have 2 over 3. And out at the beginning, I still have my 8 3/4. Okay, everybody good so far? Lovely. Now, these two, as we mentioned before, have the same denominator, just like they did before. So I can go ahead and combine them, and then I can worry about combining with the 2/3 in a moment. So this is a 4 still. So this would be 10 over 8 and 2 over 3. Now, if you want to leave it as 10 over 8 and keep working, you can. But you might at that point recognize I could reduce the 10 over 8. And anytime I have the ability to make my fractions smaller, especially when I'm trying to combine fractions together, it's going to keep numbers in general smaller. So it's kind of a nice thing to do to go ahead and reduce this. It won't kill you if you don't, but it's kind of nice. So I'm going to choose to divide these two by 2, which is going to give me 10 not 10, sorry, 5 over 4 plus 2 over 3. If you don't like the 5 over 4 and you want to actually go ahead and make it back into a mixed number here, you could. If you want to wait to do that until the end, that's okay too, or at least to a further along step. So do you want to change the 5 over 4 into 1 1/4 now or later? Later, okay. So if we deal with it later, right here, we're going to add these two fractions together. So I have 5 times 3 is 15, plus 4 times 2 is 8 over 12. I have my 4 here at the beginning. And I have 8 3/4 minus this. So what is 15 plus 8? 23 over 12. Because we're subtracting, it's probably a good idea to at least now go ahead and change the 23 over 12 into a mixed number. It's not going to entirely help us because we're about to run into a slight problem, but it's not bad. I mean, it goes in one time and it leaves me with 11, right? So this is 1 and 11 over 12. So the 4 here adds to the 1 and 11 over 12. So I have 5 and 11 over 12. It's almost like saying I have, muffin tins that hold 12 and there's 23 of them, so I have one full muffin tin and I have 11 of the other 12 still filled in. All right. So here's the deal. Whether you do the subtraction at the beginning or whether you do the subtraction as in distributing the subtraction, you have to make sure it distributes both to the whole number piece and to the fraction piece. So what is here is really 8 minus the 5, but also it's 3/4 minus 11/12. Okay, the fractional piece also gets subtracted off. It's negative as well because it's inside the parentheses with that 5. The 8 minus 5 is fine. That's 3. I can use my process with my face, if you will, to simplify this one, and that's okay. But what you will notice really quickly is that we're going to end up with a negative here in a moment, so let me show you. So I have the 3 times 12, which is 36, minus 4 times 11, which is 44, and 4 times 12, which got awfully large awfully quick, which is 48. So what is 36 minus 44? Negative what? And my denominator is 48. Again, at some point we're going to have to reduce, and we're somehow going to have to subtract these. So when we were doing addition, like if this said 3 and 8 48ths, aside from reducing the 8 over 48, we'd be done. But it doesn't say 3 plus 8 over 48, and I can just push them together. It's a subtraction sign. Agreed? We actually have to do an operation of subtraction to get the answer here, whereas the operation of addition just looks like you just stick them next to each other without the plus sign between, right? So let's reduce this first, and then I'll show you what we do in order to actually do the division. 8 and 48 both divide by 8, right? So we'll just divide them both by 8. If you weren't quite sure about that, you could divide them by 2 or even by 4, and you'd eventually get there as well. But this is actually 3, and I have a negative 1/6. Okay, so now I know the parallel is not perfect in terms of value, but imagine that you have a dollar bill, $3 bills, and you're trying to give somebody back a quarter. Okay, I realize this is 1/6 and not a quarter, but just pretend for a moment. What you'd actually have to do is you'd have to take one of those $1 bills and you have to break it apart into quarters, right? Like physical coin quarters. That's what we're going to do here as well. We're going to take one of my ones and I'm going to break it into quarters, or in this case, sixths. Sixth, that's not a word, but pretend. Sixths. So you've got 6 sixths. There's too many THs there. And I have minus the 1/6 here. So now I actually have the ability to take my 6 sixths and take one of them away and give it away or let somebody have it back or whatever I'm supposed to be doing with it. So that leaves me with 5/6. And this is again in yards. I got to be real honest with you. I don't know that either of these methods is particularly easier than the other one. They're both pretty ugly. Agree? I mean, you have a lot going on. You have common denominators you end up with, improper fractions in the middle, or you have improper fractions to deal with at the end. They're just flat out ugly problems, either way you do them, okay? All right, one last thing in this section, then we'll pause and be done with 6-2 for today. Convenient fractions. Convenient fractions are fractions that are roughly equal to what we're given, but they're easier to work with. So fractions like these would sort of fall in the category of convenient fractions. 0, 1/2, 1/3, 1/4, 1/5, 2/3, 3/4, 1, etc. Yes, ma'am. Oh, I'm sorry.
Sorry, I didn't want to go back to the other one, but just quickly, like if we had a test or something, would it matter which way we use?
So that's a good question. So it depends on the directions that I use on the test. So I have done it before where I let you pick. I've done test questions like that before where I have you do it both ways. It probably wouldn't have quite so many subtractions or quite so much chaos going on in the middle of it if I wanted to do it both ways. I mean, we got a time limit here, right? But you should know both ways because I could ask for either one or both, yeah. Thank you. Okay, the problems that you have that relate to convenient fractions are almost given to you like multiple choice questions. So they're not quite exactly just like, which one, how could I change this fraction so it's easier to work with? But they give you some options, and there'll be options kind of like these that say, which of these is the closest fraction to the one you're working with? But it's easier to work with than this ugly thing you've got. For example, if you had 12/78, that is not pretty. And I do realize we could divide them both by 2, but it's still not nice. However, it is approximately equal to 10/80. So if you adjusted the 12 and you adjusted the 78 to something that's really close to it, but not quite the same, so that they divide out easier, 1/8 is approximately the same as 12/78. It's not exact. That's why I've got these tilde curly things going on right here, right? The approximation symbol. But it's close. In each case, so they'll give you some like choices to make from. But this is one where if I were wanting to deal with this fraction and wanted to do an approximation, 1/8 would be a good choice. It does ask us, is your estimate high or low? And I'd like for you to think about what's happening as you make those values change. On the top, if I take 12 and I turn it into 10, I've made something smaller, right? Right? I'm using a smaller numerator. I have fewer cupcakes to split between my 78 people. I only have 10 of them. And if I make my denominator bigger, that also creates a smaller fraction. Because I've got more people I'm dividing something among. So if I've made my numerator smaller and I made my denominator smaller, then not that I made the denominator smaller, but I made the denominator to make the fraction smaller. Right? This fraction became smaller. Then overall, this is a low estimate. It got smaller than it originally was. If you think about this 2/1001 and you compare it back to some of these options in here, what is it almost?
0.
It's almost 0. So as you make these comparisons, they're going to tell you specifically what to compare it back to. But you're looking for what these actually are. If you were just trying to sort of, like eyeball guess it, you might say that this is sort of close to 2/1000, right? And 2/1000 is actually the same as 1/500. But 1/500 is very, very small. It's almost nothing. Almost 0. Now, 0. Is it a high estimate or a low estimate for the number 2/1001? It is low. It's smaller than what I started with, right? So we would say that that is a low estimate. Okay, I know we don't have too very long, but there doesn't make any sense for us to start 6-3. So we're going to go ahead and do group work. There's only 3 problems right here. That doesn't mean that they're really fast problems. I don't really quite remember. Sorry about that. But go ahead and start taking a look at the group work from 6.2, and 6.2 will be due next class period. And we'll start 6-3 then as well.